So, good morning everyone. Myself is Dr. Ajit Kumar and I am faculty in the Department of AC at the Presidency University. So, we'll continue our next lecture on the instruction set of 8051 microcontroller. So, in the last class, we have discussed about the few arithmetic instructions. Okay, for example, we have done this add instruction, subtract instruction. Okay, we have done this INCs. Okay, rotate instruction was also covered in the last class. Okay, two instructions are still there, which is CPL and swap. Okay, so this CPL is basically used to complement, okay, used to complement the values of accumulator register. Okay, so this CPL, you can see the operand is A. Okay, so just CPL stand for complement, so you know this what is complement is. C Okay, this one is CPL. Okay, CPL stand for complement. See, okay, this stand for complement, and this complement means to complement means 0 will be converted to 1 and 1 will be converted to 0. Okay, and this works on only one operand, and that is accumulator data. Okay, so it is going to work. The syntax is CPL and A. Okay, so what is the meaning of this? Complement all the bits. Okay, complement all the bits of 8051. Complement all the bits of 8051. This is the meaning of this instruction. Okay, so let's take one example. Suppose that I've taken the example, let's say in the register A I have moved the value of something like 5 to H. Okay, and let's say that I have written here CPLA. CPLA. Now after this instruction, what will happen is the value of A, let us write this value of A in the binary form. So you know this 5 is written as 0101 and 2 is written as 0010. So after this was before. Okay, so this is before CPL instruction. Okay, and the value of A after CPL will become 1 0. This 0 will become 1, 1 will become 0, 0 will become 1, okay, and so on. All the bits will be complemented here. Okay, so this is after CPL. Okay, quite easy. It is going to complement each bit of the register A. Okay, then one more instruction is there, swap. Okay, this swap means, okay, this swap also works on the A data only. Okay, here the operand is all A only. Okay, so SWAP. Okay, swap A. What is the meaning of this instruction? It will swap the lower nibble of A with upper nibble of A. Okay, so that means you know that in register A I can store 8 bit. So the lower 8 bit will go in the place of higher, the lower 4 bit will go in the place of higher 8 bit, higher 4 bit, and the higher 4 bit will go in the place of lower 8 bit. For example, let's say I have written here move A comma has 5 to H. Okay, and then suppose that I'm writing this instruction swap A. Okay, so it is going to, you just write what is happening is here also before, so before swap instruction A value was 5 2. Okay, so 5 is 0101, 2 is 0010. So after swap, okay, after swap this, okay, this upper 4 bit will go in the place of lower 4 bit, and this lower 4 bit will go in the place of upper 4 bit, and you know that this 4 bit is called nibble. So I'll say that upper nibble and this lower nibble. just exchange the upper nibble with the lower nibble. So what I will get is, after swap, I will get the value of A is 25H, that is 0010, and 5 is 0101. Okay, this is the purpose of CPL instruction, swap instruction. Okay, now let us come to the logical instruction. So we have here logical instruction means AND operation, OR operation, XOR operation. Okay, so the AND is represented by ANL, OR is represent all the mnemonics of OR is ORL, the mnemonics of XOR is XRL. Okay, and all these works on the accumulator only. Okay, there is only one operand here. Oh, sorry, two operands are there, source and destination. So as I said, okay, all the arithmetic and logical instruction, the should be destination should be A. Okay, the destination is always going to remain as A. So let us see all this with example. Okay, so ANL, ORL, and XRL. Okay, so let's say here I'm writing ANL. Okay, and this is going to perform what is, I mean, just let me write ANL, ORL, and XRL. So we have here three instructions. Okay, now ANL means perform logically, and okay, it is going to perform bitwise logical and operation between source operand and destination operand. This is the meaning of this structure. Okay, so there are two operands here, source and operand, or source and destination, and the syntax is ANL. Okay, the source is always A, destination could be register, memory, address value, or immediate value. Okay, similarly here ORL means it is going to perform logical OR. Okay, logical OR operation. So this is logical OR operation between destination and source. Okay, and the syntax is here also ORL A, comma, the destination is always A, the source could be register, memory address, or immediate value. Okay, similarly XRL means logical XOR operation. Okay, between source and destination, and source. Okay, so the syntax is same, only this XRL will come here. The destination is A, source could be register, memory, or immediate value. Okay, let us take what some example here. Okay, suppose here I am taking register A is one of the operand, I will take in register A, another operand I will take in register any register. Okay, so what I will do is, let's store some values in register A. Okay, let's take F2 and another value. Okay, now when you are going to use this pound sign, and if the first digit is more than 9, then you have to place here 0. Okay, that is the way that you represent any number which is greater than 9 here. Okay, and then let's say I'm having another register, let's say R0. In that one I'm storing 5 to H. Okay, now suppose that I'm going to perform AND operation between the content of register A and R0. Okay, and so what is going to be done here is, here A is A. Okay, and R naught. So it is going to perform the AND between the data of A and R naught, and the result will be saved in A. So let us take the value of A. A is F2. So F is 1 1 1 1. 2 is 0 0 1 0. Okay, then we have another one, R naught. R naught is 5. So 0 1 0 1. 2 is 0 0 1 0. Okay, so now let us try to perform. Now what I said, as per the definition, it is going to perform logical AND operation between the two bits, and you know that truth table of AND. Okay, you know the truth table of AND. So suppose that this is your AND gate. A and B are the inputs, Y is the output. So you know that the truth table is something like this. A and B are the inputs, Y is the output. So if both input is 0 0, the AND of 0 0 is 0. If A is 0, B is 1, the AND of this will be 0. Similarly 1 0 and will be 0. If 1 1, then 1. Okay, this is the truth table of AND gate. So here this 0 will be ANDed with this 0. Okay, the first bit, okay, will be ANDed, then second bit will be ANDed, like this. The AND operation is done here. Okay, so I'll do this AND operation first of all between 0 and 0. So it will be 0. The AND of 1 and 1 is 1. Then AND of 0 0 1 0 1 0. Okay, so I got here this as 5 and this as 2. So I got the new value of A as 5 2. So this is the answer. Okay, so you can see here that when you want to mask the bits, okay, then you can perform the AND operation with the any other data which is having zeros. Okay, suppose that let's say I have here 5 2h, or let's take any other number like 32h. Okay, so if 32h is there and I want to make this 2 as 0. Okay, so 0, that is I want 32 become 30. So what I'll do is I will move this 32 in, let's say, register A, and I'll perform AND of this 32 with F0. Okay, so that is like this: move A comma has 32h. Then I will do the AND operation A and L of A with immediate value. So let us take the immediate value as F2h, sorry, F0h. Okay, so here I have to place 0. Okay, because F is there. So again just do the AND of this 32. Okay, so this 32 is that is 0 0 1 1, and 2 is 0 0 1 0. Similarly this F is 1 1 1 1. Okay, and this is 0. So 0 0 0 0. Now see here, I'll get 0 0 0 0. Okay, and this will remain the same value, that is this one only, 1 1 0 0. So this one I got 3, and this one I got 0. Okay, so I got 30h. Okay, so what I said, that any bit, any number which you want to make 0, you can AND it with the another operand having 0. Okay, like that we do, and it is called masking. So this is the logically AND operation, okay, which is done bitwise. Okay, similarly you have this one which is OR operation. So you know, in the OR operation, this is the OR gate. Okay, A and B are the inputs, Y is the output. So you know the truth table of this one: A and B are the inputs, Y is the output. So you'll get the OR of 0 0 is 0, the OR of 0 1 is 1, OR of 1 0 is 1, and OR of 1 1 is 1. So that is, if any one input is 1, the output will be 1. Okay, so let us try to see some example. So let's say I want to do OR between the value of A and another one. Okay, another register value. So I'll write it like this: move A comma, let's take same value 5 to h, and another number, move R1 comma has to 5h, and perform the OR operation, ORL, between the content of A and R1. Okay, so you can do this one quite easy. So what I will do is, So 52 is written as 0101, 2 is written as 0010, and 25 is 0010, 5 is 0101. Now R of 01 is 1 1 1 0, and R of is 1 1 1 0. So this is 7 and this is also 7. So 77H, this is the new value of A, because A is the destination. Okay, so you are going to perform the AND of this sorry, OR of A and R1, and the result will be saved in the A only. Okay, because it is destination. Okay, likewise in the XOR also you can see it is going to perform XOR operation. So you know the truth table of XOR gate. Okay, if A and B are the inputs. Okay, so this is XOR gate and this is the output Y. So you know A and B are the inputs, Y is the output. Let us take 0 0 0 1 1 0 1 1, and we know that if there are odd number of ones, the output will be 1. So in these two cases there are odd number of ones, so output is 1 and the rest will be 0. Okay, so this is the truth table of your OR gate. So let's try to perform the same thing. Okay, let's take this same example, this move this number. Okay, here also, so let's say that A is containing 52 at 52, A is containing 52. So 5 is 0 1 0 1 and 0 0 1 0, and another number is, let's take R1 is 25. So I'll take 2 as 0 0 1 0. 5 is 0 1 0 1, and perform the OR. So it will be 1 1 1 0 1 1 1 0. So I got here 7 7. Fortunately both answers are coming same. So this is also 7H. So this is the new value of A, which is destination. So this is how we perform the OR operation. Okay, that is AND operation, OR operation, XOR operation. Okay, so these are called logical instruction. Few CLR means it is going to clear the content of any register. Okay, for example, uh, CLR, I will see the CLR here also, because you can see here CLR is here also, CLR is here also. Okay, bit related instruction it is, which is used to clear the certain bits. Okay, this we'll see here. So now let us, now this JNC JB, okay, this should have been in the jump instruction. So this is jump instruction. I will discuss the jump instruction. Okay, here this one I had discussed yesterday. Okay, this RRC, this ANL. Now this ANL, ORL, okay, they can be used to perform on one bit also. Okay, so that is, you see here, if you see this one, we have done here between the 8 bits. When I was doing AND operation or operation XOR operation, I was taking 8 bit, and though bitwise they were being ANDed or XOR, but we can do this AND or XOR between 1 bit also. So in that case, the 1 bit, mean there should be 2 operand. One operand should be definitely in the carry bit, okay, carry flag bit, and another one should be in let's say here, that bit can be specified directly here. Okay, so I will just show you. Okay, that is bitwise. Okay, we have bitwise also, bit logical instruction is there. Okay, in which we have like ANLC, sorry, ANL, and we have here two operands. One operand should be the carry flag bit, another bit should be written directly here. Similarly, ORL, between again 2 bits we can do C, carry flag bit, and another bit should be mentioned here. Similarly, XRL, between the carry bit and another bit should be here. Okay, so what is happening, let's say I'm going to show this one. Suppose I've written set B carry flag bit, so you know this C will become 1. And let's say I'm writing here another instruction ANL C comma 0. Now what is going to happen is, it is this instruction is going to perform AND between, okay, C, okay, is ANDed with 0. Now what is C here? It is 1. Okay, so 1 and with 0, you know, it will be 0, and this 0 will be saved in destination. Okay, so this operation after this operation, C will become 0, and initially it was 1. Okay, this is how it works. Similarly, okay, another thing is there. Suppose I want to perform this, C, let's say I've written this one, uh, okay, set set B C. So you know this C will become 1. Then I will write this same one, A N L C. Now let's say I want to perform C. I want C to be 1 and another operand as, let's say I'm writing like this, has, okay, this one, slash 0. Now slash 0 means it is not 0. Okay, not 0, and not 0 is 1. Okay, so this, always remember, when you are placing slash sign, then it becomes complement of the bit which is mentioned here. Okay, so here I'll get the complement of 0. Complement of 0 is ANDed with C. Okay, the complement of 0 is ANDed with C. So what is going to happen here? The C is 1, and because this bit, okay, this bit, okay, is equals to 1. Okay, because it is not of 0, not of 0 is 1, so it is 1 ANDed with 1, and you will get 1. So your final answer C will become 1. Okay, this is so, and okay, this is how it is written. Suppose that you have written A N L C, okay, then you have written a slash 1. So slash 1, this is equivalent to 0. Okay, the not of, or the complement of 1 is 0, so you'll get here C is 1, so 1 is ANDed with 0, and you'll get 0 answer. Okay, so bitwise also we can perform. Okay, likewise you can do this ORL between C, okay, C or the another bit. Okay, similarly this is XOR. Okay, so XOR of C and the another bit. Okay, this is how it works. Fine. So actually this one is actually bit related instruction. Okay, this bit related instruction is supposed to be in this part. Okay, in the next category which is going to be discussed here. So the next category of instruction is bit related instruction. Okay, so bit related instruction means we have two instructions which is very important, CLR and set B. Okay, these are used to clear the certain bit and to set the certain bit. Okay, so for example, if you are writing CLR C, so in that case C will become 0, and if you are writing set B C, then in that case C will become 1. Now it is not necessary that it is going to only work on the carry flag bit. We can do this on any bit also. For example, set B PSW.4. Now remember, this PSW.4 was actually RS1. Okay, so RS1 flag bit of your this register, PSW register, 0 1 2 3, okay, and so on. Okay, so this flag bit will become 1. This is the meaning of this one. Okay, like that you can also set the any port bit. Okay, for example, set B P1.2. so like if you are going to do this way, so your port pin number 2 of port 1 will become 1. Okay, this can be performed on any bit, and similarly this CLR also can be performed on this one, CLR, okay, P1.2. so in that case this port pin number 2 of port 1 will become 0. Okay, so it can, CLR and set B instruction can be used to do used to clear or set the certain bit of either carry or any particular bit of your bit addressable memory, okay, or bit addressable bits of registers, okay. So like this we have these two instructions. Okay, now in this case we'll study some this one. Let us try to understand jump, that is conditional branching instruction. Okay, let us try to understand branching instruction here. So the next category is branching. Now this branching instruction is very important. Okay, you just see here, when suppose that why this term comes branching, I'll explain you. So generally what happens when you write the instruction like this, move a has 5 to h. Suppose that you are writing like this, move r naught, okay, has to 5h. Let's say I have written add a comma r naught. So in that case, and then you are writing end instruction. So you know the this instruction will be faced, decoded, executed. Then this instruction will be faced, decoded, executed. Then this will be faced, decoded, executed. Like this, all the instructions are being executed one by one in a sequence like this. Okay, so this is, I mean, a straight process. Okay, here the flow is straight, but sometimes we may not need in our programming, it may not be so simple. Okay, for example, suppose that you want to find the factorial of a number. So you know that factorial of any number, let's say 5 factorial is 5 into 4 into 3 into 2 into 1. Now in this case you cannot do I mean you may perform in this case like flow, straight flow instruction, okay, but that will lead to longer program. So to make the program smaller, we use branching instruction. In the branching instruction, what happens? This is the flow, and it's okay. This branching may occur like this also, or it may occur like this also. Okay, so this is actually called branch. Okay, so where we need this kind of branch, basically when you want to repeat certain set of instruction. Okay, when you are going to you repeatedly execute a certain set of instruction multiple times, so in that case you are going to use this kind of branching instruction. Okay, so this branching instruction is of two types. One is called conditional branch and another one is called unconditional branch. Okay, so this branching instruction is of two types. Okay, one is called conditional branch instruction, and another one is called unconditional branch instruction. So what's the difference between these two is, in conditional branch, if certain condition is true, if certain condition is true, then branching take place. Branching takes place. Well, I'll explain you this with some example. Whereas in this case, without checking any condition, okay, without checking any condition, without checking any condition, branching takes place. Okay, uh, some examples I'll give here. Conditional branch means like JZ. Okay, JZ means jump if 0. So it is JZ, then JNZ. Okay, other example is JC. Another example is JNC. So these are called conditional branch instruction. I will talk this conditional branch instruction, okay, later on. This side we have example like S jump, L jump. Okay, these are unconditional jump, means unconditional branching instruction. Without checking any condition, it will directly jump to the specified level. Okay, So we have these two categories of conditional and unconditional branch instruction. uh, this branching instruction, we have another one which is called call instruction. That call instruction I will explain you separately, okay, where we use call instruction to branch to the subroutine. Okay, so that is also a class one category of branching instruction, but we will not mess up that concept here. Okay, so we'll talk about that one later on. So let us try to understand this few conditional jump and unconditional jump instruction. Okay, so just J's, let me check these instructions which we are going to discuss. L jump, A jump. Okay, A jump is also there. So these are unconditional jump instruction. Unconditional. So A jump is also there. uh, this JZA is not actually, this A is not there, it is not mentioned. J, then J and Z, okay, is also there. So let us try to understand this conditional unconditional instruction here. Okay, now this side, okay, let us try to understand first of all conditional jump branching instruction. So the first instruction is JZ. JZ means jump if A is 0. Always remember that it is going to jump to this. Okay, if the condition is A should be 0, if A is not 0, it will not jump. This is the condition. Okay, and this is written as JZ, and then we write here label. Okay, so if so in that case, what is the meaning? If A is 0, then jump to label. Okay, now see here, what is happening is, we'll take one example. Okay, suppose I'm writing here like this: move A comma has 5 to H. Let's take this, let's say I'm writing this one: SUBB A comma has same number 5 to H. So now you know here A value is 5 to H, and here the A value will be equals to A minus 5 to H. So this, after this instruction, the value of A will become 0. Okay, now you know that value of A is 0 because same value we have subtracted here. Now let's say that I have written here, let me erase this one. So let's say that I have written here JZ jump if 0. Which value it is going to check? The value of A register. Okay, so let's say I have written here jump 0, and here I'm going to write the name of label. So I'll write here next. Okay, now suppose that below this one is some other instructions. Let's say add A comma has 5 to H, and then another instruction I'm writing here is move A comma has, no, not this one. Suppose I'm writing another add instruction: add A comma has 25H, and let's say this next, which is the label name, is here. Now you see here what is happening is, this is called, this is the place where the instruction will be, the program counter will be jumping to. Okay, so what is happening is, this value was executed, so you got A equals to 52H. Then this instruction was executed, then you got A value equals to 0. Okay, so A is 0. The next instruction is saying check the value of A, that is jump if A is 0. Okay, so the meaning is jump if A is 0. Remember, it is always going to check the value of A. So in that case, the microprocessor is going to check the flag register. You know that in the flag, no, not sorry, so here it is not going to check the flag register. It is going to check simply the register value A. Now A value is 0, so it is true. Okay, so true means it is going to skip this instruction. So this instruction will be skipped. This instruction, which is the next instruction, is will be skipped. Why? because the instruction is saying it to jump to the level next. Where is next? Here. So it is written like this only, next colon, okay, and then suppose that this instruction is written, so directly the processor will come here. The processor will jump to this instruction, which is add a comma hash 25h. Now after executing this instruction, the value of a will be a plus 25h. So you know this previous value of a was 0, so that 0 will be added with 25h and new value will become 25h. Okay, so this is how this instruction jz is working. Okay, so it is going to check the certain condition. If that condition is true, then it will directly jump to the label which is written here. Okay, the label name could be anything, but don't mess up it with your mnemonics of any instruction. You cannot write here this label should not be any instruction. Okay, it should be any other words. Okay, any other words, but that words should not be starting with any integer value. Okay, this suppose that you have written like this, jz move. Okay, now you are saying that this is mnemonics. No, this is our move instruction, so this will be wrong. Suppose that you are writing here jz1. Okay, you are writing the label name as 1 Ajit, so this is also wrong. This label name should not have the starting letter as digit. Okay, then jz you can write like next, correct. Zz you can write anything, back, this is also correct. Okay, so this label name should be written correctly. Okay, you cannot write any instruction in the place of this label. Okay, so likewise we have another instruction. The opposite of this jz is jnz. Jnz, okay, the meaning is jump if not 0. Jump if not, okay, jump if a is not 0. Okay, always remember it is going to check the value of register a is not 0. So suppose that same set of instruction is written here. Okay, the same set of instruction. Okay, here also I'm assuming that the same thing is there. So suppose example I've written here, move a comma hash 52h. Same thing, move sorry, subtraction is there. So sub a comma hash 52h, and the next one is jnz, jump if not 0, and suppose that I have written here in next. Okay, instead of jz I have written here jnz. Let's say the below instruction is same only. Okay, that is add a comma hash 52h, and suppose that here add a comma hash 25h, and here this is next where it is jumping. Okay, now in that case this instruction will be executed, so the value of a will become 52h. This instruction will be executed, then the value of a will become 0, that is 52 minus 52, so your a value is 0. Now this instruction will be executed. Here the processor will check the value of a, which is 0, and it is saying jump if not 0. If the value of a is not 0, then jump to the label next. So do you think that this condition is true? Okay, what is the condition of jumping? If a is not 0, then jump to next. Okay, however we know that a value is 0, so this condition is false, and in that case the next instruction will be this one. Okay, so this instruction was previously skipped in this case, but here it is not going to be skipped. Here this instruction will be executed. Okay, so you know the value of a will be equals to a plus 52h. So previous value of a was 0, so that 0 will be added with 52h, so the current value of a will become 52. Then this next instruction will be executed. Okay, that is obviously it is going to follow the sequence if the condition is not true. Okay, so if the sequence is, if the condition is true, then the sequence will be not followed and some kind of branching will take place. Okay, So here no branching, same sequence is followed. So here this A will be performed, that is A equals to A plus 25h, and you can add this 5 to plus 2 5, so you will get 5 plus 2 7 and 5 to 7. So this is the new value of A. Okay, so these are the two conditional instructions which are J, Z and J and Z. Okay, then third one is JC, okay, which is called jump. Okay, the meaning of this one is jump. Okay, in fact it is written like this, JC, and here the label is written where it has to jump. So meaning is jump to label if C is 1. Okay, jump if carry is 1. So this is the meaning. Okay, just opposite to this is J and C. The meaning of this one is jump to the label. Okay, jump to label if C is not equals to 1. Okay, C is not 1. Okay, that is, this is equivalent to C equals to 0. Okay, if it is not 1, so obviously carry flag will be 0. So the meaning is jump if C is 0. Okay, that is jump if no carry. If no carry means basically C is 0 only. Okay, this is the condition of jumping here. Okay, so let us try to understand this JC, JNC from the same example. Okay, it's another example. Suppose that I have written here move a comma has, let's take this is 80h, and another instruction is there, add a comma has same value 8h. Now suppose that I have written here JC skip. The name of the level is skip, and let's say that I have written here add uh, a comma has 25h, and here is the skip level where it is to be jumping. So let's say here I'm writing anything like SUBB a comma has, let's say any value to 3h. Okay, now let us see here. First this instruction will be executed, so the value of a will be 80h. Then this will be executed. Okay, so you know the value of a is equals to a plus 80h. Now let us try to perform this addition. So this 8 is 8, a is 80, 80 means 80 means 1 0 0 0 and 0 0 0 0 will be added with 80. So I'll write here 80 value, that is 1 0 0 0 0 0 0 0. Let us add it, 0 plus 0 0 plus 0 0 plus 0 0 0 0. Now 1 plus 1 is 0, and then a carry will be there. So this bit carry is there, so you know C is 1. So you can see here, after addition of this, after executing this instruction, okay, after executing this instruction, C value is now 1, that is carry flag has set to 1. Now just below that instruction is JC. JC is saying that jump if there is carry. Okay, jump if C is 1. Where to jump? To the list level is skip. Now you can see that this condition is true. There is a carry generation before executing this instruction. So the C value is 1. So the condition of jumping is true. And so the processor will jump directly to this instruction which is specified at this level. Where this level is here. So processor will directly jump to this instruction, and this will be skipped. Okay, this instruction will be skipped here, and this directly will be executed. Now according to this one, the value of a will be a minus 23h. Okay, so that is previous value of a was 0 will be subtracted with 23h. Okay, this is how actually it is going to work. Okay, so this is the meaning of JCJ. Okay, the likewise we have JNC, jump if no carry. So suppose that I would have written here, instead of this instruction JC, let's say that I would have written this one. Okay, instead of this instruction, let's say I would have written here J and C and skip. Now see here, because before this instruction the value was a plus something and C was 1. What is the meaning of this one? Jump if C is not 1, that is C is 0. Now you can see the condition of jumping is not true. The this instruction is saying to jump to the skip if C is 0, but we know that C is 1. So in that case it will not jump to this skip level, but it will execute the next instruction. Okay, so the next instruction is add a comma 25. So your A value will become 0 plus 25 inch. Okay, and then this instruction will be executed. Okay, this is how actually this JNC instruction works. Okay, these are called conditional jump instruction. Okay, they are very important. Fine. There is another one which is called DJNZ, decrease and jump if not 0. So that is very important instruction. Okay, that will instruction will continue in our next class. So till now, thank you everyone.